Hello students, so hope you all are doing well. So I have in the preceding lecture I have already introduced what median is, and I had also solved one problem related to it. So I have taken the same data here. Here I have taken the same data and I have already introduced what is known as cumulative frequency. Okay, so we have taken a data of this form 0 to 10, 5. So that means marks scored in the range 0 to 10 is 5 students. So there are 3 students who scored 10 to 20 marks, 4 students who scored 20 to 30 marks, so on and so forth. This is our data. This is taken from the preceding lecture itself. Now, this cumulative frequency table are of two types. One is less than type and the other is more than type. Now, please understand very carefully what is less than type and what is more than type. It's very simple. Actually, it is. If you think it properly, it will be very much feasible for you all. But if you don't think, you just keep on mugging up, then it will be a bit of problem for you all. Just try to understand what I say now. See, so let's check the same table. I have taken this data in this form. Marks scored by student range 0 to 10, 10 to 20, 20 to 30, so on and so forth. Frequency, that is number of students who are scoring in this range, 5, 3, 4, 3, so on and so forth. Now, what are the number of students who scored 0 to 10? That is, you can say less than 10. Less than 10. Less than 10 marks is scored by 5 students. Okay. Now, how many students scored marks less than 20? 10 to 20 means less than 20. 10 to 20 means less than 20. Obviously, 3 students have scored in the range 10 to 20, and there are these 5 students also who have scored just 0 to 10. That is 0 to 10 means that is obviously less than 20. So what we do is we add this 5 plus 3 will give you 8. Are you understanding? Similarly, 20 to 30. How many students scored marks less than 30? Obviously less than 30 is scored by this, and obviously this. So 8 plus 4 will give you 12. Are you understanding? Similarly, what are the number of students who scored marks less than 40? So less than 40 means obviously these three. Those who scored less than 10, less than 20, less than 30. Obviously they scored less than 40. So basically 12, and you need to add up this. So this will give you 15. 15 plus 3, 18. 18 plus 4, 22. 22 plus 7, 29. 29 plus 9, 38. 45, 53. This is how it goes. Are you understanding the logic behind it? The logic is fairly simple. Students who got less than 10, automatically they will get less than 20. So we have to add them up. Students who got less than 30, automatically they'll get less than 20. So you have to add it up and you have to continue it. So this type of frequency distribution is called less than type cumulative frequency table. Less than. Students have scored less than 10, less than 20, less than 30, so on and so forth. Okay. Now there may be a reverse case of this, what we call more than type. Now in more than type, what happens? There obviously it is the vice versa. So number of students who scored more than 10 or more than 0. Number of students who scored more than 0. Obviously all the students scored more than 0, isn't it? 53. How many students scored more than 10 then? More than 10? More than 10. Now what we will do is, we will subtract 53 minus 5. How many students scored more than 20? Obviously 45. 48 minus 3. Then 45 minus 4. Then 41 minus 3. 38 minus 3. 35 minus 4. 31 minus 7 is 24. 24 minus 9 is 15. 15 minus 7 is 8. Are you understanding? Now basically the funda is same. Here what is happening? Number of students who scored less than 10 and number of students who scored less than 20. If I say number of students who scored less than 20, obviously the number of students who scored less than 10 also needs to be incorporated, right? But here, so that is why we were adding up. But here, how many students scored more than 0? All the students. All 53. Are you understanding? Now, if we are increasing the max, if we are saying more than, for example, more than 90, there are very few students who scored more than 90, obviously. How many students? You keep on decreasing. And to decrease, you just keep on subtracting. That is it. Are you understanding? Here we have to add, and here we have to subtract, and it goes in the reverse manner. Is it fine? Please go through this very carefully. Now, our major concern will be less than type. Obviously, more than type will also be dealt when you are when you draw the plot graphically. But here our concern will be on the less than type. Okay, so let me rub this up because there's very little space on the board. I have been trying to adjust it. Now, let us come back to what we are doing. We are talking about median. So for this distribution, what is the median? That is the question. Median is the question, isn't it? We have been discussing about the median. Now, median is expressed by using this formula or this expression. Median is equal to L plus n by 2 minus cumulative frequency divided by f into h. Now, what is L? L is the lower limit of the median class. Now, lower limit of the median class. Now, here we need, just like if you remember we had done model class, here we have something known as median class. Now, what is median class? Median class is given by n by 2. What is n? N is the number of observations. How many observations are there? 53. So, 53 divided by 2. So, this will give you 26.5. Now, 26.5, check where you will have 26.5. So, here we have 22, here we have 29. So, 26.5 is nearest to 29, isn't it? So, the median class corresponding to this will be 60 to 70. So, median class is 60 to 70. This is our median class. Are you understanding? What we will do? Median class is given by n by 2. Because we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 distributions, isn't it? N by 2. N by 2 means n is 53. 53 divided by 2 will get 26.5. You check this cumulative frequency is nearest to which range? This term which you got is nearest to which cumulative frequency? Obviously 26.5 is closest to 29. It's not closest to 22, isn't it? So the class interval corresponding to this cumulative frequency is called your median class. So here our median class will be 60 to 70. It's fairly simple. So once you identify your median class, now your job becomes fairly simple. Median is equal to L plus n by 2 minus Cf divided by f into h. Now all the terms are known. L, lower limit of median class. What is the lower limit? 60. So median will be equal to 60 plus n by 2. N by 2 means 26.5, 53 by 2 minus cumulative frequency. Now this here you have to be very careful. Cf is the cumulative frequency of the preceding model class. Now this is our model class. Preceding model class is this. Obviously 50 to 60. It is the preceding. So you have to use cumulative. That is 22, isn't it? Minus 22 divided by f. Now f. What is f? F is the frequency. Frequency will be 7 into h is the class size, which is 10. It is obvious. It is obvious. Is this understood? Because of shortage of space. So L is 60 plus 26.5 minus 22 divided by 7 into 10. Now this you can easily solve. And you can get your median. Let's try it out. 60 plus this will be 4.5 divided by 7 into 10. So this will be 60 plus 45 divided by 7. So this will be around 6 point something. 60 plus 6.3. That means 6.4 to around 6.42. So this will give you around 66.4 as your median. So this is how you calculate. Basically what we will do, less than type, you keep adding the frequency, keep adding in the cumulative frequency column of the preceding frequencies, and for more than type you have to subtract in the reverse order. You use this expression where all the terms have to be very, very clear to you. From there you will get your median. This is important from your examination point of view as well. Please go through this properly. I'll solve some problems related to it in the next class. So for the time being, we'll stop here. Thank you so much.